having a look here at exact trigonometric ratios or exact trigonometric values. There's three main values we deal with when we're talking about triangles. When we extend this beyond triangles to angles of any magnitude, it becomes an infinite number of angles, but they're all based on these three angles, 30 degrees, 45, and 60 degrees. We then using some double angle formulas or compound angle formulas. We can do some other angles as well, but these are the three ones that everything's based on. So we start off with two triangles, okay? Our two triangles are two pretty simple, right? Well, our first one is not a right angle triangle, but we turn it into one by splitting it in half. We have an equilateral triangle that for ease of numbers, we say has side lengths of 2. We drop a perpendicular bisector down the middle there, and what we end up with is then we split these two in half, so we end up with those lengths. That 2 becomes 2 lengths of 1. So we can focus on either of these triangles here. We started off with an equilateral triangle that had a 60-degree angle there. We put a 90-degree angle into it there, so that means this top one must be 30. Okay, so as you can see, that's two of our exact value angles, 60 and 30 degrees. Now we need this height. Using a little bit of Pythagoras' theorem here, this height is going to be h squared equals 2 squared minus 1 squared. So h squared is 3, or h is root 3. Positive value only because it is it's a length, can't be negative. Okay, so now looking at this here, this is where some of our exact values come from. So sine of, if we start with 30 degrees, sine 30, going from our top angle here, is our opposite 1 over our hypotenuse 2. Cosine of 30 is our adjacent root 3 over our hypotenuse 2. And tan 30 is our opposite 1 over root 3 adjacent. To 60 degrees in the bottom left of the triangle, we're going to have sine 60 equals our opposite root 3 of our hypotenuse 2. Cosine 60 equals our adjacent 1 of our hypotenuse 2. And tan 60 equals our opposite root 3 over our adjacent 1, which we just call root 3. So we've got our exact values there for 30 degrees and 60 degrees for sine, cosine, and tangent. Now, you might be looking at that going, do you have to remember all of those? Well, you really don't have to remember them all. Once we start to get into trigonometric identities, we can see that there's some overlap here, right? You already can probably see it. You may just not know why it's happened. The relationship between sine 30 and cosine 60, well, they give the same value because cosine is the complement of sine. Okay, so that's always going to be true, that sine 30 equals cosine 60. In the same way that sine 60 equals cosine 30, they're both root 3 over 2. Now, the relationship between tan 30 and tan 60 is that they are the reciprocal of one another. Okay, so one is 1 over root 3, the other one is root 3 over 1, which we just went and called root 3. So you don't necessarily have to remember 6 different values and then add another 3 in for 45 as well. It actually kind of boils down to kind of like if you can remember 3 numbers, 4 numbers, you're actually pretty good with this. There's some tricks on your calculator as well that you can use. You can type those into your calculator and square them and see what comes out. And then remember to take the square root backwards of them. And that can give you, for example, if you had cosine 30 and typed in your calculator, you end up with a very messy decimal, but you square that, you get 3 over 4. Now take the square root of that, you end up with root 3 over root 4, which is root 3 over 2. Just a little trick as to how you might be able to find those exact values if you do draw a blank. The triangle that we use to find some exact trigonometric ratios, or exact trig values, is an isosceles triangle. It's a right-angled isosceles triangle. And again, for ease of numbers, we pick 1 and 1 for those sides. By doing a little bit of Pythagoras, we end up with root 2 for our hypotenuse. 1 squared plus 1 squared is 2. Take the square root of that, you get 2. This actually works if you pick any number. If you go 10 squared plus 10 squared, if you pick 10 and 10 instead of 1 and 1 for those sides, you'd end up with the square root of 200, which is 10 root 2. So all we've done is multiply all those sides by a factor of 10. it actually does boil down to the same thing, because we'll be able to get rid of those common factors as we go through. Let's have a look here. We've also got 45-degree angles at both of those vertices. So we actually only need to do 3 values here. We don't need to switch angles like we did last time for 30 and 60. So if we go sine 45, well, that's opposite of 1 over root 2. Cosine 45 is also 1 over root 2. The opposite and the adjacent are equal here, which means it doesn't matter where we're looking from. And tan of 45 is equal to 1. Okay, 1 over 1, which is just 1. Now, I alluded to a couple of things before, that the sine of an angle is equal to the cosine of the complement of the angle. Well, 45 is the complement of 45, so it's no surprise here that sine 45 is equal to cosine 45. In the same way, we said that the tangent of an angle, the complement of that angle is going to be the reciprocal of the tangent of that ratio. Like what we said, we had our exact value of tan 30 is 1 over root 3, and tan 60 is just root 3 over 1. Well, the same is true here. Tan 45 is 1, and the complement of that is also tan 45, which is still 1 as well. So that's our 9 exact values. Once again, you don't really have 3 numbers to remember here. Sine 45 is equal to cosine 45. They're both 1 over root 2. And if you type tan 45 in your calculator, you get 1. It's a very easy answer to get there. I hope this has helped with some exact values.